It's really my honor to introduce Professor Yale Patt from University of Austin, Austin, here today. Let me say a few things about Yale. I've known him for just about half my life, actually a little less than that, but soon it will be half my life. He's been a very powerful influence in the area of computer architecture. He has influenced a great many chips and computers, ranging from probably the VAX all the way to the Intel Pentium 4. And if you look on his website, you can find many honors and awards that Yale has received over the years. But before we showed up today, I asked him, if I were to convey to the audience one award you'd hold up amongst the others as the best, he received recently an award from the graduating seniors at the University of Texas, the professor who is most likely to be confused as a bum. But by the police on campus, and by some students too, I imagine. Anyway, I won't take too much time here, as Yale has a very interesting talk to give us, which he has entitled Stew. So, Yale, thank you.
So, before I sit down, I was hoping I could move this over there, but I can't because the cords are not long enough. So, what I propose to do is I've listed a whole bunch of bullets, and what we're going to talk about is up to whatever you want to talk about. A couple of years ago, I noticed that you talk for an hour, and then you say, okay, now we have 5 minutes for questions, and the first couple of questions make it clear that you didn't say anything for that hour that anybody was interested in hearing. So rather than do that, I came up with the title, Are There Any Questions? So I'd get up and say, are there any questions? And then we could go for an hour. And for this audience, I said, let's do some, how about doing this? And the organizers said, yeah, that sounds fun. So some of those bullets are very high-tech. I can tell you, what the microprocessor 10 years, I think, is going to look like, what some of the serious challenges facing microarchitects are. Or we could talk about, what is the defining document of the United States of America? Which is a very different discussion. And there's other things, should football players be required to take courses, et cetera, et cetera. I did bring a few extra transparencies in case you guys wanted to talk about, for example, advice for your first year in graduate school. We can talk about that. I believe that it's important. In fact, I think it's up there someplace that writing and speaking are important. My high school principal used to say, what a man, now today we would say man or woman, but back in those days there were only men. In fact, the founding fathers had that problem also, but we corrected that with turns out we keep correcting it, although some people want to uncorrect it with the amendments to the Constitution. But so what a man knows or what a man thinks is lost if he doesn't have the ability to express it in oratory or writing. And so I believe that you ought to learn how to write, and we can talk about that. I also have my how to get and keep a job, which I think is important. We can talk about that. Or we can talk about whatever you want to talk about. And so, any questions? Yeah, go ahead. It's an excellent question. Not what I had hoped that we'd talk about today, but I can go on for, we can do a whole hour on that. So one of the most serious problems today And in fact, I don't know how many of you are interested in computer architecture, but computer architecture, first of all, is the interface between what the software wants done by the microprocessor or by the computer and what the hardware delivers. And so computer architects are particularly well positioned to understand both or to influence both. So my PhD students, for example, take courses in operating systems and compilers and all that stuff because they need to know what the hell people need us to be pushing to build. Similarly, they also take VLSI design courses and that sort of thing since they need to know the stuff, the circuits that we're going to require being built. So we're at the interface. And I think it's clear that we need to influence the programming model. That is, that we need to somehow, and we keep paying lip service to it, but I think we're now at the point where we have to, we were at the point 10 years ago where we should have started paying attention to it instead of paying lip service to it, of the programming model. How do we express the things with concurrency so that, in fact, the multiple cores on the chip are going to be able to deliver the performance we need? There are a couple of reasons for multiple cores, by the way. So one reason is that you can run multiple cores at slower frequencies, and so you can consume less power that way. There's another reason for doing multiple cores on the chip. So, the Pentium 4 is what? 65, 75 million transistors. In fact, so you asked the question, so you know what this is? Yeah, it's a keychain. Why do they always get that wrong? Yeah, it's the original Pentium chip, and it's 3 million transistors, 1992. The first microprocessor was what? The Intel 4004, which was 2300. So 2300 transistors in 1971, 3 million transistors in 1992, 65 million transistors in 2000. Now we've already got chips that are over 1 billion transistors, and the number keeps going up. So you say to the designer, here you got 1 billion transistors. Design. Who, me? So, I know what I'll do. I got 1 billion transistors, and it takes about 50 million transistors to do a Pentium 4. What does 50 go into 1 billion? I learned that in second grade, 20. So boom, 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 boom. Bingo, I've got my billion transistor multiple core. So it's not just this power saving, it's easier. Right? So those two forces are both working, and they're both important forces. Niagara, product by Sun. The first product is 8 processors. They can each run 4 threads. A thread is an instruction stream. They do it in a very boring way. No out-of-order execution, no branch prediction. They fetch and decode 1 instruction at a time, each thread. Very boring, but you can get 8 processors on that one chip today. Tomorrow it'll be 16 processors, then 100 processors. It works if the program can take advantage of it. Now, there are some applications that it's obvious. It's the AI-ish kind of applications where you can embarrassingly generate threads to work on a problem. But there's still a lot of stuff that doesn't do that. So what do? Some of the stuff will be done by things like operating system, where you have multiple cores and they're each working on separate pieces of work. But if the purpose of buying or making an expensive chip is that you want to be able to solve a problem faster, then we need to work on the programming model. And so I think that was probably your suggestion that we need to, and the answer is yes, we do need to. Because the number of cores, Justin Ratner, who's a very senior guy at Intel, in fact, a couple of years ago I was talking about a billion transistors on a chip, and he says, Yale, you're not thinking far enough ahead. It's going to be 10 billion transistors on a chip. And there's going to be 2,000 cores on a chip. Now, do I believe 2,000 cores? Well, I'm not so sure. But the numbers are going to continue to get bigger. By the way, there is a thing that Gene Amdahl discovered a long time ago with respect to this business of embarrassing parallelism, that there's a part of the problem you can't do anything about. You know, it's got a name that goes something like Amdahl's Law. And if you want, I can go to Blackboard and, you know, do all the defining for you. The point is that there is a factor called alpha, and for that fraction of the problem that can't be parallelized, you're sort of stuck. So on that very large number of cores on the chip, you're also going to have a couple of serious cores. I call it the chip, the Pentium X Niagara Y chip. The Niagara Y, so right now we have Niagara 1, we got Pentium 4. I don't know whether it's going to be Niagara 15 and Pentium 73, I don't know. But there's going to be lots of cores to do this parallel thing, but there's also going to be the time when you need the Amdahl's Law part of the problem with the serious branch predictor and the out-of-order execution and the wide issue and all that good stuff. The programmer can help. In fact, there historically has been this thing that you've got problems, and they're described in natural language. I don't know, English, Spanish, French, whatever. What do you call somebody who speaks 2 languages? Bilingual, good. 3 languages? Trilingual, 1 language? American, good. You all know that one, right? All right. Yeah. So you're doing some natural language, and then you convert it to an algorithm. Then you convert it to a mechanical language. We call that a program. And then you translate it to the ISA. And then you implement the ISA in a microarchitecture, which is then implemented with circuits. And then finally, down at the bottom, it's the electrons that are really doing the job. Right? So how do we get from here to here? Global optimum would be great. You know, you walk up to the computer and you say, electrons! You know, solve the problem. We can't do that. But why is it that people work at a layer and you sort of don't cross the layer? I think those days are over. In fact, one of my younger colleagues, professor in ECE, Professor Wenmei Hu, has a white paper saying that we need to break those artificial layers, and at the programmer level, the programmer got to be aware of what's done in the microarchitecture, what's done by library routines, and pull all that stuff together. Okay, so I've wandered enough. Did I answer? I don't know whether I answered your question in any of this or not. If not, then try again. I'm sorry? An interesting answer, but I didn't deal with the question. You want to try the question again? Or is that sufficiently that I should move on? Damn, why did I give him that opportunity? While you're thinking, go ahead. There was a question over here. Yeah, go ahead. Is there anything that people don't know about? No, everybody knows everything about everything. So why is it that even though everybody knows everything about everything, we still get this sequential code that people write? There have been attempts, by the way. You know the Transputer, which is a computer made, boy, I've forgotten the name of the company already, but back in England about 20 years ago? More than 20 years ago now, the Transputer came out. The Transputer, the product, was actually not step one. Step one was the language, OCCAM, O-C-C-A-M. And they said, okay, now we need to build a machine. And they had structures in OCCAM like, you know, do in parallel. Somebody came up with Paralisp, for example. Dave Cook, right here at the University of Illinois, when he was parallelizing the Fortran compiler for the ILLIAC 4 and then the CEDAR project, which is a very important project that came out of this department back in the through the 80s, actually. And so Fortran you don't know, because Fortran is old and boring, and, you know, there's still more Fortran code out there than any of these other sexy languages like, what, C, C++, what else? No, Java's a religion, not a language. So he came up with this thing called do all, right? Which means that so we'd say for all, I guess, if you're programming in a more modern language, right? For all, which means that each of the iterations of the loop are independent, vectorizable. So we've known everything, but yet, and we've had these forays into parallel programming, but still, I remember one of the Army centers, and they had 64 processors, and they had an 8x8 array, and you could look at each of these 64 squares, and you could tell how busy the square was by the color. If it wasn't busy at all, it'd be white, and if it was, going full bore, it would be red. And so what do you think you saw? 1 red, 63 white, So yes, it's all out there. But somehow we still think sequentially. Is there any reason for that? I don't know. In fact, there's probably people in this room that know far more about, the cognitive processes than I do. I'm just a poor dumb engineer who looks at this and says that no, most of the code tends to be. Yeah, go ahead. Pride yourself? So that's like girls priding themselves that they can't do math. It's nonsense, Yeah, so I think, the punchline I already gave you, which was what my principal said, that, when you graduate, you're a student? Yeah, recently graduated. So 5 years from now, you come back and tell the people here, say, what is it that's important that you learn? Or what does your job depend on? It's your ability to speak and write. If you can't convey the information, what good is it, Tips on good writing? Oh, okay, sure. Be happy to. That's that slide. Should I put it up there? You like that? Make me get off my butt. Huh? Yeah, we can talk about that. And by the way, there's nothing in the X and Y chromosomes that say that girls can't do math and boys can't write. It's a cultural nonsense that's been, over the years. My kid sister was a much better mathematician than pretty much anybody that I saw growing up. Problem she had was that our high school teachers knew no math. My ex-wife knew no math. She was one of them. She made A's in geometry. How'd she make A's in geometry if she couldn't do math? Geometry, by the way, is probably the best course she ever took in high school. How could my ex-wife make A's in geometry if she understood nothing? Oh, teacher would come in and put all the proofs on the board, and she'd write them all down, and then the night before the exam, she'd memorize all those proofs, and then she'd come into class, and sure enough, he'd ask her to prove something that he had put on the board, and so she'd get a perfect 100. So I was home visiting my folks, and my sister comes up to me, and she's taking geometry, and she says, I don't understand what I did wrong here. This proof has got a 0, and I've gone through it 100 times, and I can't figure out my mistake. So I looked at the proof, and there was no mistake. And then it hit me, because I had, it was a funny thing. I went to the same high school my kid sister went to. So I knew the math teacher that she had, and his problem was he knew no math either. And so what he would do is the night before he would copy from the book the proof onto his page. And then in class he'd put the proof on the board. And the kids would take the proof down, from the notes of the teacher to the notes of the students without going through the brains of either. And then they'd memorize the proofs. And then he'd come into the exam and he'd, ask them to barf it back. The problem was my sister had 2 big brothers who taught her math. So she never memorized the proof. So she'd go in the exam and she'd say, okay, what is it I'm supposed to prove? Now, how do I do that? And, most of you guys are not math challenged, so you know how to prove something. You don't do it by memorizing. In fact, that's part of the big problem with introductory programming in high-level languages, that the kids don't get it, they just memorize. Memorize is bad. Understanding is good. So what does she do? She figures out how to prove the theorem. Problem was, the teacher didn't know enough math to be able to follow her proof, so she gets a 0. So I wrote in the corner, I said, this proof is completely correct, deserves full credit. So what did he do? He gave her full credit. I'll never know whether he did that because he knew that I wouldn't grub for points for my kid sister, or he's afraid I'd turn him in. That I don't know. Anyway, writing. So those are the tips on writing, and they're not all that hard. In fact, some of my worst writers are the top high school graduates in my own country, and the reason for that is that the high school English teacher is so happy that you can get the plural noun, plural verb right. And the high school teacher is so paying attention to the kid who can't do that your crap gets an A. And I studied Latin. I probably had more Latin than half of my English teachers in college, probably. 4 years of high school Latin. The thing called ablative absolute has no business in technical writing. Short sentences are better than long sentences. In fact, they're all up there. Short sentences are better than long sentences. The verb is the most important word in the sentence. Active is better than passive. Never use a big word when you can use a little word. In fact, I think it's up there that the only 5-syllable word I ever use is delicatessen. In fact, I had a student, but the problem is you come out of high school and you've been patted on the head for doing bad writing because you got it all right. You can do a sentence and have a gerundive in there that works. It's absolutely correct. Nobody thinks like that, People think in little words. So use little words, The thesaurus. In fact, I think that's up there. The thesaurus is better. If you've got a table with 4 legs and one of the legs is smaller than the other 3, the thesaurus could be better served by just propping up that 4th leg, So I have a dictionary. In fact, it's not okay to make spelling mistakes, and spell check will not catch all your spelling mistakes. In fact, I think I got that up there also, and I spell all, A-W-L, which is a perfect, and catch, K-E-T-C-H. Those are perfectly good English words, and spell check won't catch them. So what I never make spelling mistakes. Never. Sometimes I have dyslexia of the fingers when I type, and so my secretary will often see that I instead of saying T-H-E, I say H-T-E. That's not a spelling mistake. That's a dyslexia mistake of the fingers. And I figured it out, by the way. It's because I'm right-handed, and I touch type, and my right hand goes faster than my left hand, and the T is with the left hand, the H is with the right hand, and so the H comes down before the T goes down, even though the T starts first. But the H catches up and goes ahead. Fascinating, right? So how can I possibly be a perfect speller? I have a dictionary next to my desk. And if I don't know how to spell the word, I look it up in a dictionary. How big is a dictionary? Small. It's a pocket dictionary. Well, what about a big dictionary? If the word isn't in the pocket dictionary, you probably shouldn't be using it. Right? Use little words. I had a colleague at Michigan. Every 10 years I move, which Professor Patel is one of my Michigan PhDs, and he didn't tell you that. Every 10 years, when they steal me away and they offer me instant tenure, since I'm old and decrepit and don't hear so good, I hear 10 years. So after 10 years, I gotta move on. So I had a colleague at Michigan, and he says, "You're supposed to be a great teacher. Let me tell you what I do. Why do I keep getting bad evaluations?" And I said, "Sure, talk to me." He said, "Let's go to the union. I'll buy you the fanciest latte that you could ask for." And so we did. Told me all the things he'd done. I said, "Wow, you must be a great teacher." He said, "Then why do I get such terrible evaluation?" He cared about the students. He'd ask for feedback. He would look at the homework, and on the basis of things kids got wrong, he would overdo the Next lecture, he did all the right things. Terrible evaluations. I says, I don't know. I don't know what to tell you. You know, everything you're doing is right. So then I had occasion to listen to him give a talk. And then after the talk, I went up to him and I said, you know, it's going to cost you another cup of coffee, but I know the problem. In the middle of the talk, he used the word aphorism. I said, nobody knows what an aphorism is. He said, of course, everybody knows what an aphorism is. Right? No. Some people do. Some people have maybe some idea, but it stops the brain, see? So you're going along aphorism. What does that mean? So you have to figure it out. Meanwhile, he's gone over to here. What you need is words that are simple enough so that the brain doesn't have to stop the focus on the word. It's true in speaking. It's true in writing. Right? As I say, the biggest problem is high school English teachers. You know, Dykstra had a, go-tos proved harmful. I say high school English teachers proved harmful. Ending sentences with prepositions. That's a little stupid. You know, Winston Churchill, who's arguably one of the best writers of the English language. And what did he say? He said, that kind of nonsense, the rule of ending sentences with prepositions, he says, that kind of nonsense, up with which I refuse to put. You know? Now, better if you can rework the sentence so that you don't need to end it with a preposition. But if you can't do that, it's better to end it with a preposition than have some awkward sentence. You know, so the most important thing about writing is, I think it's the first one up there, is keep in mind the reader. Why are you writing? You're not writing for you. You're writing for the reader. Yeah. You know, there's a fantastic textbook, Introduction to Computer Systems. You know, they use it over at ECE, the freshman course. Yeah, read some of that writing. It's incredible. Yeah. For those who aren't enlightened, I wrote it, or at least I wrote part of it. Professor Patel wrote the rest of it. In fact, he allowed me to be his co-author on the book. Introduction to Computer Systems, Computing Systems from Bits and Gates to C and Beyond. We paid attention in that book. We get feedback all the time. Wow, what a greatly written book. Wow, I can understand it. What we did when we wrote the book is put ourselves in the minds of the freshmen. Say, okay, how can we explain it so that the kid will get it? And if you do that, if you keep the reader absolutely prominent in your mind, your writing will go up by a lot. Don't consider writing as a disgusting thing that you have to do. You know, writing is not cleaning the oven or the toilet or anything like that. You know? Writing is an opportunity to get your ideas out there. And sometimes we guys avoid writing. That's what girls do, you know. No, that's nonsense. You know? Yeah. Change the subject? Sure. Go ahead. So is it really bad as he makes it out to be? Yeah. So what you really want, so a long time ago, a guy named, so he started it, actually. Dykstra doesn't always get credit for it. He started it. A guy named Harlan Mills at IBM often gets the credit for it. Actually, the original paper, I think, the fancy paper was Jacobini and Beam. And the concept of structured programming. And the reason why Harlan Mills gets a lot of the credit for it is because he was a manager at IBM, and he had, how does he get good code? You got 100,000 lines of code. Nobody can write 100,000 lines of code, right? So you do this, you do this, you do this, you do this, right? Well, now you need clean interfaces between the parts. You need to organize it. Also, it's a case that if you've got 100,000 lines of code to write, and you've got this huge team, probably none of them are really super duper. So how do you get great code written by mediocre people? So he lifted this concept, structured programming, systematically decomposing the problem. Go-tos, and well, let's go over here, and as soon as you do that sort of thing, you break something that wasn't taken into consideration will often just break your program. So that's the reason they're harmful. Is that they're probably harmful more because on a complex piece of code to keep track of everything that can. What you want to do is be sure that you're in control of what it is that you're writing. And this go-to, over there, is it the case that when you go to over here that everything that could have happened if you went down this path is still the way you think it is? And so this concept, structured programming, systematic decomposition, stepwise refinement, all these terms they give for it, it's a good argument. Right? Yeah. Somebody else first, or go ahead? Somebody else first. Go ahead. On net neutrality. So, is it true that Yale Patt has an opinion on everything? Tell me more. Where are you coming from? Yeah. Yeah, of course it's not right. I'm sorry? I'm sorry? So he said something wrong? Go ahead. No, go ahead. This is supposed to be all of us. Go ahead. Unless you want to go first, since he's already... You'll defer to him. Is he the hotshot? He's the hotshot. You graduated already. Well, then your brain has already started to calcify, You're never going to be as smart as while you're still a student. Anyone. So that means you can pick on them? Go ahead. Go ahead. You agree with all that, or you want to add? You're all right. Yeah. Go ahead. You have to speak up. Everybody can't hear you. Anybody else? So why is it that we have this problem? If it's not that the government wants to regulate it. You got it. Because companies want to make money. So if I go to Intel and I say I want one dual-core chip, should I get the same price as Dell gets when they go to Intel and they say I want 500,000 dual-core chips? Should I get the same per-chip price? I guess you could say they should, but there is economies of scale, that play out. The thing is far more complicated than for me to come up with a simple answer. Corporate America is there to make money. Do I like it? I think if corporate America didn't make money, our quality of life would probably go down. Do I like the abuses that some bad citizens in corporate America do? No, I don't like that at all. It's a tough balance, and I haven't totally figured out my opinion, if you will, on net neutrality, but I can see these opposing forces at work. What might even be worse, by the way, is if the government does end up getting in there and regulating it. Now, if this were America, and the government were the government of the people, by the people, and for the people, then I might let the government regulate it. But unfortunately, too many times those regulations tend to exacerbate the problem rather than fix the problem. So I think what you've touched on is a serious problem, and how it all plays out, I don't know. Incidentally, I don't know how many of you are familiar with it. There is a collection of people who by definition are called interesting people, abbreviated IP, which I think is a great play on words. A professor used to be at Penn, Moore School, who's now at Carnegie Mellon, Dave Farber, and he has fancied himself the repeater station for the interesting people of the world. And what happens is, if you want to join that, you send email to I guess it's dave@farber.net, and say I want to get email from you, and you will get about 20 or 30 email messages a day. You might consider it spam, or you might consider it useful stuff, depending on the issues involved. And net neutrality is one of the I would say you probably get a half a dozen email messages on net neutrality. The point is that there are a lot of people out there that spend their lives thinking about, is what Google doing right, for example. The issues that that Farber forwards has to do with computers, has to do with communications, has to do with government regulations, has to do with problems in the world. Some of us can't seem to get past the fact that there are things that our country is doing that we're not happy with, and so that plays out in this email you get from him. You get about 20 to 30 messages a day, and of course you can just delete. In fact, most days I have to, because I can't deal with the other 150 messages a day, so it's a sort of a luxury. But if you're interested in this topic and other topics, so the business of, in fact, that was the main point of doing this talk called STEW, which is, as technical people, we do care about what the microprocessor is going to look like 10 years from now and whether or not we have to change the programming paradigm. But we're also citizens that ought to care about a lot of other stuff. And so this IP list is a way to make yourself abreast of all this stuff. And the guaranteed net neutrality is part of it. Go ahead. So let's finish up this one first, I think. Yeah, go ahead. You want to do an unrelated also? Okay, well, let's do his unrelated, then we'll do your unrelated, okay? Yeah. Let's get this first slide back up. Yeah. I'm sorry? How do I do what? be an interesting professor and lecture and turn them on, see? In fact, in this audience are some of my former Texas students that decided they really wanted to get a strong graduate degree in computer architecture, so they didn't stay at Texas. They came to Illinois, right? How do you get them interested in computer architecture? Yeah, how do you get people interested in running for president? There's only one at a time, you know, so it's not a big business, but yet there are all these politicians that want that job, yeah? Yeah, so we may not be as big as some software yo-yo that writes this boring code, you know, that falls asleep in the middle, you know. But we're the most important part of the computer spectrum. We're at the interface, see? We have this particularly great thing that we have to be aware of the needs of the software, and we have to produce something that actually, at the lower level, will carry out what the software wants. We're not the only game in town. In fact, as I told you, that I have my students take circuits courses, they take OS courses, they take compiler courses. So do I have the largest group? Probably not. I would guess that, in fact, so what's the most important single problem in computing today? You know, you've got a laptop? Yeah, so what's the most important problem? And architects haven't taken a serious look at it yet. We got to. No, actually, it's something more important than power. What's going on in his head? Nobody can read my mind. Damn. Huh? Somebody said it. Good. Security. How much would you give to know that your machine could never be violated? See? And name a secure operating system. There ain't one. There ain't one. It's all nonsense. It's only how much you're willing to pay to violate, how much you're willing to pay to make sure you don't get violated. And so there's that balance. So we still have to solve the security problem. And the OS people and the network people and the architects have to get involved with this. And we do some stuff, you know, tagging memory, for example. That's a start. It doesn't do the job, you know. So the point is that as time goes by, you know, so you had this Intel 4004 chip. You know, computers computers even, forget microprocessors. Computers, they have a thing called a cache. There was a time when we didn't have caches, you know. In fact, you probably learn in some introductory course that there are 3 address machines and 2 address machines and 1 address machines and 0 address machines. What's a 1 address machine? You've got a single accumulator. You want to add 2 numbers, you go to memory, you get a number, add it to the accumulator, and put it back in the accumulator. We don't do things like that anymore. Okay? First of all, we have lots of registers because they're cheap. Then we come up with caches where I've got all this data and instructions on the chip that I didn't have before. And time goes by, and the challenges keep on. As we understand more and more, the challenges just keep on coming. Right now, I'd say the biggest challenge is security. Power is certainly important. It's critically important. But security is the one problem that I think architects need to get involved with. So your question, how do I turn on students? I don't have to. I mean, the problems are there, you know, if we're willing to address them. And, you know, there's still companies out there. The reason why the people say computer architecture is dead, they say, it's all x86. You know, x86. What's x86? If you look at an 8086 in 1979 when it came out, and an x86 today, there's a hell of a lot more stuff that goes on now than, you know, back then, right? So I guess I've been lucky. I haven't had to turn on students to computer architecture. They see it and they come running. Yeah. What do you think? Not the Constitution. Why? So go ahead. No, go ahead. With your foreign accent. Where are you from? from? What's your last name? From the accent alone. I was going to say Israel, actually. Is that correct? Israel? No, Israel. It's a small country that's surrounded by... It's kind of like Austin. You know, sometimes I think Israel's like Austin. You know, we're not in Texas, but we sure as hell are surrounded by Texas, you know. So why you say not the Constitution? The last U.S. president who paid attention to it. I'm sorry? No, go ahead. So what do you think a defining document is? No. It's not supposed to be the Constitution. In fact, the Constitution is really the codification of the defining document. He happens to be right. And in fact, when they came up with the Constitution, they got it wrong the first time. They did. What's the most important sentence in all the documentations of the United States of America? We hold these truths to be self-evident, that all men, today we'd say all men and women, are created equal. They are endowed by their Creator, not my Creator, their Creator, with certain inalienable rights, that among those are life, liberty, the pursuit of happiness. That's a defining sentence of the United States of America. When they came up with the Constitution, they got it wrong. Fortunately, they were bright and they cared, and so they came up with the first 10 amendments to the Constitution to try to get it right. And time has passed, and there's been a few more amendments since. The fact that some president either does or does not ignore it, it's up to you. You're a citizen of this country? No. Well, you have friends that are citizens? You care about this country. You do. You clearly care about this. If you care about the world, you have to care about this country. We happen to have some influence in the world. That influence may be declining, but it still exists. And we're also the biggest bully on the block, see? And we're also a lot better than most other countries, by the way. Go around the planet sometime and say, gee whiz, you know. No, things really are better here than in most other places. But, you know, the French say noblesse oblige. You understand that expression, noblesse oblige? No. Nobility obliges. So, you know, I no longer own a car. I sold when I left Berkeley to move to Michigan, I sold my California car because it never would have, you don't want to undercoat a car after you've driven it for several years, because if you go over railroad tracks, you'll lose the undercoating. So I sold the car with the idea of getting a new car in Michigan, and I finally moved to Texas. I never bought a car. So I've been without a car as an American kid who, when he was 16 years old, you know, you need to have a car. Pick up chicks, right? I mean, the real reason for a car. No, most of the chicks have their own cars, so I don't need a car, see? There's a parking lot next to our building. And if there's a football game, in Texas, by the way, the number one religion is not Java, it's football. Right? If there's a football game on Saturday evening, they do not allow students to park in the parking lot next to the building on Friday night. It took me 6 years to fix that one. But I finally did. And I just pushed and pushed and pushed, and finally they decided, I have this fancy title at Texas, so they finally gave up and said, okay, fine, we'll leave the parking lot open until Saturday morning if there's a football game Saturday night. You know, I don't know how many people park for a game Saturday night on Friday night, but that didn't carry any weight. There was an argument that actually carried the day, but the point is, where am I going with this thing? The point is that I got the parking lot released for students. Why? Because that's the way my mother raised me. Noblesse oblige. That your job is to take care of those who don't have the clout. If you've got the clout, your job is to protect the people who don't have the clout. This is a big country, and it's a good country, except that somehow some people have lost their compass, and it's up to us to make sure that we get back on track. That defining document, that defining sentence, you get to worship the God of your choice, or no God, if that's your choice. You know? I've had Christian students that tell me that if the Bible is in disconnect from the Constitution, we follow the Bible, because God knows what's better. You know? No, that's not my country. My country says, you decide that I have enough trouble figuring out how I should live. I don't have time to figure out how you should live. That should be your job. Right? And if you believe that and you're not a citizen, you need to get your citizen friends to vote for people who believe that. Yeah. I'm sorry? So that's why up there is that, I think it's one of my bullets up there, that engineers should be required to take more humanities. You need to, first of all, be aware of what the problems are. That's number one. Right now, the most serious problem facing this country right now, today, we have an election in 2 weeks. Now, you can't vote. I can vote. And I will vote. And I pray that my vote gets counted the way I had intended it to be. That's a serious problem in this country right now. And technological people have a responsibility to speak up. There's a kid at Rice University, is a young associate professor, Dan Wallach, and that's his research. So what do you do? You know, it's funny. You may not realize it. You probably think, I'm just a geek, But when you go to a party and you talk to people, they have a lot of respect for you because you know computers and they don't. And so you have a responsibility to let them know about these issues. Do you understand the issue completely? Probably not. But you understand it a hell of a lot better than these other people do. And so you have a responsibility to speak up, And, that's true of everybody in, this is a technologically savvy room, And you can look at yourselves as nerd central, and you don't go beyond that, or you can look at yourself as having a responsibility that does go beyond that. And people will listen. How many of your friends that ask you which laptop they should buy? Yeah. So those people that ask you which laptop they should buy, you should also tell them, we have a problem with these Diebold voting machines. Okay? Next question. Yeah, you haven't spoken yet. Go ahead. I'm sorry? Well, I got news for you. Great book. Tom Friedman, New York Times. The World is Flat. You read it? You know about it. You're aware of it. You haven't read it yet. Well, knowing about it is step one. Picking it up is step two. Reading it, step three. All right? Yeah. So it turns out that we're going to see before much. We're already seeing it today. There's a great country in South Asia called India. You may have heard of it. Fascinating country. And when I was, 20 years ago, the flow of students kind of come to the U.S., to learn. And then once they learn, they stay. Well, they stay in spite of, the ties are back to the mother country. So that's why every December, the airplanes go to India. And then after Christmas, the airplanes come back to the U.S. And you can't get a seat hardly unless you make your reservation 6 months in advance. 10 years from now, I don't think you're going to have to worry making a reservation in advance. A lot of kids are not coming. A lot of kids, once they get done, they go back now. And it's going to get more and more. The world is flat. There's a thing called the Internet, you might have noticed. And so it is not the case that you have to come to the U.S. to get educated. You can sit in some cyber cafe and surf the web. What the Internet has done is level the playing field like nothing before. And so, American companies that are going to India to get the job done, you say, how come? They can get it done cheaper? In many cases, they can get it done better. It's not just getting it done cheaper. There's a lot of cases where they're going to India to get it done better. Chinese are also woken up, you know. So as time goes by, we already see the trends. We need to do something about that. We've already seen the trends, and if we don't wake up, not only we're not going to be the U.S. prerogative, we're just going to be just another country out there. And I think the Internet has a lot to do with that, because you no longer have to come to the U.S. for information. In fact, there's a big push that, so I'll give a simple example, which is not really a great example because it's got too many problems with it, is Wikipedia. I know a lot of people that they want to know something, they go to Wikipedia. The problem with Wikipedia is, of course, that the stuff is only as good as the people who are posting it. But as time goes by, that becomes better. Because it won't be long before the posting is going to be controlled. Like if it's nonsense, it goes off of Wikipedia. You know, maybe that's already happening. I don't know. But as more and more knowledge gets made available, independent, you don't have to come to Champaign. You know, I love Champaign. It's the only place I can run 4 miles and get back to where I started. And if I keep my eyes in this direction, I can look at corn all the time, you know. This is a great place. It's a great place because of the collection of faculty and students. You know, that may change. If you don't have to come here, you can sit in Bangalore and, you know, so that's why I say that it's no longer a U.S. prerogative. We do have to pay attention to the rest of the world. You know, the U.S. has always been, we can do it. We can, you know. Yes, I can. Famous book. We are a nation of problem solvers. We have been a nation of problem solvers. I frankly think the fact that we're an immigrant country has helped that. You know, first it was the English, and then the Irish, and then the Italians, and then the Jews, and then the Chinese, and then the Vietnamese. And there's always these immigrants who want to do more, and they work harder. You know, but if we get lazy, there are plenty of countries out there willing to eat our lunch. So we need to pay more attention. We live in a world. We don't live in a country. Yeah. So that's my harangue. Yeah. I'm sorry? As opposed to being right next to each other? Oh, absolutely. So people tell me all the time, distance learning, forget about lectures, you know. They tell you all these things about lectures that are bad. What they're really talking about is bad lectures, which will always be bad. You know, you get this, you know, so the professor used to get these yellow notes that he'd put on the blackboard. I already gave you that line, you know, from the notes of the professor to the notes of the student, without going through the brains of either. Now the bad lecture is not done that way. Bad lectures are not done from the notes to the blackboard. They're done by PowerPoint. Professor gets up there, dong, dong, dong. You know, you want to invent this metronome thing that can get up there and do that for him. He could sit in the corner, you know. In fact, those of you who are professors, if you ask your students, they will tell you that your lecture would be so much better if you'd leave your damn laptop at home. Okay? The blackboard is much better. You can build, or whiteboard, same thing. You can build the example as you go along. Distance learning, to do a lecture in distance learning takes an enormous amount more effort and time to get it right. Yeah. The problem with distance learning is that deans love it because it's cheap. And they sell it on the basis of being cheap education rather than better education. There is no substitute. You're absolutely right. There's no substitute for this, for the interaction. In a lecture hall, you know, we got what? A couple hundred people or something, whatever, in here. Be better if it was just you and me, one-on-one. That's always going to be better. But there is a magic, the chemistry. I can look in your eyes. I can tell whether you're getting it. It's tougher to do over the web. But how about the scenario where you have, I don't know, you've ever had a great Indian professor? How about if he or she decides to go back to India? And then most of the time the students are doing the web thing, but every so often they get together with that professor for the chemistry and the magic, So I hope I've answered the question. The point is that there is no substitute for the interaction, live interaction. Look in the eyes and be able to tell, is the kid getting it? Is he not getting it? But do you need that as a constant? So here we like to supplement it with web-based stuff. In fact, most professors tend to assign stuff on the web to have you go through exercises or read material or that sort of thing. India right now, or I pick on India. I shouldn't pick on India. China, whatever. These are the countries that are taking the action away from us to an extent. I was in Beijing about a year ago. It's amazing what's going on over there. I've been in India many times, and India is really 28 different countries all wrapped together as India, But it's exciting times. There is no substitute for the interaction where we're in the same room, but I think the thing is we've got to the point now with the web, the internet, that it's a viable substitute most of the time, not all the time. And in fact, I think the best thing is you get somebody over there to have that interaction, and most of the time they're spending without. For example, how many hours a week are you in a classroom? 3 hours with a professor? And they tell you, for every hour in class, you should spend 3 or 4 hours outside of class. In my classes, I'm told it's 10 or 20 hours outside of class. The point is, the 1 hour in class is important, but the actual real learning and understanding goes on when the student is working outside the classroom. The last question. Who has the chutzpah to ask the last question? Go ahead. Yeah. And what is most, expand, right. That was not a yes or no question, right. What is most important to learn is the fundamentals and the ability to think. There's a lot of this, freshman programming. Let's teach them Java. That's what they're going to, look at the ads. They have ads for Java programs. But by the time these freshmen graduate, it won't be Java. It's going to be C#. So we should teach them C#, But no, C# is not sexy enough. Java is what's sexy today. Except that keeps changing. And, 10 years from now, it won't be C#. It might be D flat. I don't know. The point is that when you look at what's out there, there are fads, sexiness. That's not what you want. It's the fundamentals. People say, if I could go back and spend a year just studying, what would I study? The answer, probability statistics. Because that's going to be important forever, say. So what's most important to learn is fundamentals and the ability to think, not memorize. Because nobody's going to hire you to barf. Well, I guess they could hire you if you want, a $5. So a guy had this experience at the airport, TSA. So now you can take toothpaste. This is on one. I got this out of this interesting person's things from Farber. So you're going to get about 10 messages a day on the absurdity of TSA theater. So the guy went through the line, and he had a 6-ounce tube of toothpaste that was less than half still there. And the rules say you can bring on 3 ounces of toothpaste. And the TSA guy would not let him take the toothpaste through the security check. He says, but you agree it says 6 ounces. And you agree that there's less than half of the toothpaste still there. And the TSA guy said, yes. So therefore I have less than 3 ounces, right? Right. So I can take it through, right? No. The rule says 6 ounces, and it says 6 ounces. So if you want a job like that, $10 an hour, then memorize and follow rules. But if you want to get the big bucks, then you should learn how to think. Okay? Okay. Thank you.